So without further ado, please help me welcome the CEO of Pegasus Imagery, Cole.
Okay, so there is 3 microphones now. All right, can you guys hear me all right? It's a pretty small crowd. All right, that works well. Awesome. Perfect. Okay, so this morning I thought there'd be a really funny treat. We're gonna fly one of the drones directly from here. Just kidding, they fly themselves, so it's a poor pun. So as Gail really very generously introduced, my name's Cole. I'm the CEO for Pegasus. We're an aerospace company based here, actually, in the Edmonton region. We're actually located about 10 minutes west of St. Albert at a regional airport called Villeneuve. So what I'll kind of walk through here, my thesis is get quickly through kind of a walkthrough on what we do at a high level at Pegasus, and then really open the floor for questions, probably some heckling from the top back row, see what else you guys would have in store. So as a company, in a broad statement, we really are building a lot of the breakthrough technology required to unlock the next century of aviation. And I'll start this by saying it has been a great 2 weeks where drones are not the boogeyman for aviation. So it's actually a really interesting segue, and I wanted to just quickly start with this because what you're seeing with all the concern and uncertainty around balloons and unidentified aerial phenomena, this is exactly a challenge that happens every day on the commercial side. And I'll kind of unpack it for about 5 seconds and move forward. So what's been released recently over the last week is that a lot of these unidentified aerial phenomena, I don't want to say UFOs or UAPs, I guess, but a lot of things up there in the sky have a very small radar cross-section. They're actually quite hard to detect, and they're very slow moving. So the radar systems have been, now this is all public, are filtering out this information. They don't want to see slow-moving, relatively small objects. Because for NORAD, they're looking at high-flying, high-speed, big challenges, mainly with countries' flags on the tail of them. So it really shows, though, at the same time this is all happening, for decades, airports have been doing the exact same thing. Now they're trying to filter out a lot of their systems to avoid birds and other small objects and focus on what their primary safety case is, detecting and tracking and supporting commercial and general aviation. So if it's smaller than a Cessna, they're gonna filter it out. And I just wanted to kind of bring this up because this is just a snapshot of what regulators around the world are facing. So, of course, as a startup here based in Alberta, the very first thing we did when we launched the company in 2018 is actually call Transport Canada the regulator. It's a shocker, I know. So as a company, we looked at the existing system. The core mission for us really continues to be how can we radically transform emergency management, wildfire. These are problems that require what drones promise, but for 20 years have totally underwhelmed and failed to really deliver on because they don't have the ability to safely fly in the same airspace as general aviation or manned aircraft, even in restricted airspace around a wildfire, and actually especially there because low visibility is a given, and there's a huge number of aircraft. They have a really hard time coordinating the whole thing. The last thing you want to do is inject something brand new into a system that has been more or less running the same way, business as usual, for 70 plus years. So this is the challenge. How do you actually integrate drones? And the answer, I think, is actually really straightforward. So there's a huge market opportunity, and I'll kind of speak to what we do at the company. We don't build drones that are really small. In fact, building and designing and manufacturing aircraft actually came quite late. We started with, from a first principles perspective, what's the enabling technology required to unlock this whole opportunity? And the short answer is, it's detect and avoid. There's a huge market coming, and we primarily focus on the 1 million drones that are going to be roughly about 100 pounds or bigger and flying long endurance, multi-hour missions. Why? Because that's probably one of the greatest early adopters for us, is looking at long-range pipeline inspection here in Alberta, utilities, and for us in particular, supporting first responders. So detect and avoid is the key technology. It's pretty much indisputable. And what this really comes down to is, how do you have a program that is reliable enough to replicate what humans do as a pilot? There's a lot of different approaches. Some
So the key drawbacks are really, they're largely limited to only being able to operate in daylight or in like good visibility conditions. There's a lot of challenges because a lot of the current kind of proposals are tied to ground-based radar, for example. That's really expensive and it's often actually really hard to move around. So you have a cost there. And then again, a lot of the current themes are really around being human-centric and focusing on remotely piloting drones from a laptop somewhere else. So I'll show you a quick example of what we do instead. So our approach is different. We look at developing aircraft that can fly beyond line of sight. And how to do that really comes down to a detection range, being able to detect day or night what else is out there, even if they're not broadcasting their position like some general aviation. This is what happens when you give me a laptop. But in short, we do sensor fusion. We take all the sensors required to do that longer range detection than what's currently available, especially on the commercial side. Air-to-air radar, computer vision, so optical cameras that can detect and track, like you see from a lot of full self-driving cars or proposed full self-driving cars. And we fuse all this on board, including a lot of the aircraft control systems. Why do we do all of this? Well, in short, you don't have a lot of time to make a decision. So a remotely piloted aircraft being flown from a laptop or even a hand controller, you have somewhere between 20 to 40 seconds to make a decision, to be able to receive that information, make a decision, have it go back, and then have the aircraft, big or small, make that avoidance. We do this in under 3 seconds right now, and we're just getting started, I guess. It's a bold statement for the team that's been here for 4.5, 5 years. The reason why is this is also a key component. When we talk about autonomy, every single person here will have a different idea of what that actually means to you. Today, 93% or more of the critical decisions or routine decisions made on a commercial airliner, they're all made by a computer. We're looking at basically taking all that existing experience and adding the last, most valuable components required to fully automate and in some cases make autonomous, deterministic decisions. So if anybody here from the University of Alberta wants to talk about deterministic AI, I will roll up my socks and we can bang it out in the Q&A. In short, put the brain and all the requirements on the aircraft itself. Why? It's the most complex way, technically, to do this, but it's also the most scalable way, and it's the most enduring, and at the end of the day, it's the safest way possible to have a system that works. So, in practical terms, what this means, our systems with this A3S, this Autonomous Airspace Awareness System, this allows us to detect, track, and have the aircraft autonomously navigate around hazards. For small drones like quadcopters that can fit in your hand, we're picking them up over 1 kilometer right now reliably. For larger aircraft, at like a 95% accuracy and confidence rate, we're seeing them well beyond what most pilots have for beyond their visual range of their line of sight. So, in fact, in a lot of cases, we see pilots before they see us. And if they do see us, we probably just look like a regular airplane to them because we have all the right navigation lights, etc. So what's that? That's a really good question. For us, it depends on what we're actually out there doing, because we're not building this technology just to have a science fair. We're a private company. In a lot of cases, you could look between 400 feet and above. It's probably an easy category. And I say that because right now, most drones can't fly above 400 feet. And the simple answer behind that is manned aircraft aren't supposed to go below 500 feet. So there's supposed to be a buffer there. And that buffer often, in our experience, doesn't always get held, right, by manned aircraft. So how does this work? We had to actually start from scratch. We couldn't afford to go to Lockheed Martin or Boeing and buy a multi-million-dollar drone that was big enough to carry all of our sensors for testing and prove that out. So with a lot of ingenuity, the team has originally went from a clean sheet design into building from scratch in our hangar at Villeneuve now 6 different versions of this aircraft. So what this means is we now have a technology demonstrator that turns out we just built a really good one. So EOS is our first autonomous aircraft equipped with all of our onboard technology. So this aircraft is, the Gen 5 of it is already flying. So the 6th version of it, which is probably the last version before full commercialization, this will be ready for next spring. So that's a lot of me talking. Why am I talking about the drones last? Well, in short, we're focused on the most complex challenge. A lot of people build drones. Drone deliveries around the world is a great example. Sure, it's a business model and makes sense to some people, but delivering hamburger helper and you don't have a detect and avoid system really limits your total reach. So we focus on autonomy and this detect and avoid capability first. Our roadmap has been obviously taking the hard road. Sometimes on the graph it looks like the high road, but in a lot of cases it's just the hard road. But our approach is actually very straightforward. Focus on solving the regulatory barrier and building the relationship, giving them the real world testing data, not just simulation, but real world live autonomous avoidances in flight, and have them use that information to have the confidence to write new rules. So we have an opportunity as a very small startup to work with some of the world leaders, as you can kind of see from a very splashy infographic. Since 2021, we've had an official partnership with Transport Canada. While a lot of people kind of look at them as, why aren't Transport Canada helping us? The very first question we had for them in 2018 was, how can we help you? And so since then, the relationship has just really grown. We work very closely with the National Research Council here in Canada. We were a NASA semi-finalist for this technology in 2020, and that was a pretty big honor. We continue to work with NASA in a couple different areas. And then there's a small company out of Seattle called Boeing. You guys might have heard of. So Boeing is a customer. They're also a partner in some cases, and they're also an investor. We have a very good relationship with Thales Group out of France, working on some of the same things. If you're not familiar with Thales, they have about half of the world's airspace management systems. So EIA here, or anywhere around the world down to Timbuktu, really, actually, you can find Thales systems controlling aircraft day to day. So, what's that?
And LRT.
No, well, not the LRT apparently, but everybody in Edmonton brings it up. And so part of this is we focus on all the different use cases that show the regulator in practice, this technology isn't just safe, it's reliable and it's scalable. And this is something that you can look at certifying as opposed to going through waivers and the whole process, right? So part of that is finding really compelling real world use cases. Like wildfire is an obvious one, so we have a partnership partially funded with the federal government, and that includes Sturgeon County at the municipal level, the government of Alberta at the provincial level as well, and some industry partners that you can see on the screen. The whole thesis for us is, how do we radically connect and help evolve wildfire management? It is a massive challenge and it's not going away. In fact, it's one of the great challenges of this generation and the next one. So how do we actually give people the information that they need to be safer and smarter? We're not telling them that we have that answer. We're working with them. And we've been doing this for the last 2 years here in Alberta. And then this year we're launching the next phase of that, really looking at adding some really cool features and some really cool use cases to prove that concept out with them. And then Canadian Pacific Railway, guess what? They have a lot of long-range track inspection that's done using very archaic systems. People in trucks or physically walking the line, or people flying a Cessna and looking out the window. You're probably not going to see what you really think you need just by trying to fly a plane at the same time and having Bill look out the window when he's flying through the mountains. So we've been able to prove out a lot of this technology through some really amazing use cases. And I'll just touch on this because we're here in Alberta, and this is actually really close to our heart and why we started the company. There's a very good kind of momentum being built. Most people look at CAL FIRE down in California as kind of the world leader when it comes to who's trying innovation or who's trying new approaches for wildfire. I'll tell you right now, the government of Alberta is a world leader in this. They have an innovation cell dedicated to this. They are putting money behind it, and we're extremely honored to be working with them in a very close capacity to help support and enable them to not just solve wildfire, but there's so many bigger effects behind it. Like wildfire in Canada is a bigger greenhouse gas emitter in most years than the entire country combined. And if you think about that for a second, you're talking about wildfires being in the megatons or the hundreds of megatons. We're all focused on self-driving cars, but wildfire is a colossal problem around the world. And for us, luckily, outside of Siberia, the world's biggest wildfire highway is about 2 hours north of Edmonton. So we're geographically sited to take on, problems of that scale. So that's a pretty quick run through on what we do here at the company. I'm happy to take any questions or heckling from the top row. Yeah.
My question is, I don't see any of your slides including insurance companies, and if they embrace this technology, instead of just a whole bunch of regulators, are they going to insure anybody operating in these spaces?
So there's two sides to your question, I think. One, are we talking to anybody from the insurance side? The answer is yes, but it may not be what you're thinking. The initial, I think your question is, are insurance companies working with drones and looking at this as an insurance space? Yeah, our insurance is 4 times in some cases. Like it's at least double of what you would do for a general aviation aircraft. And why? Because they don't know what the risk profile looks like. So insurance is actually one of the biggest costs to being able to develop and start deploying this technology.
General aviation almost died when the insurance liability laws came into effect. I wonder if that's going to affect the drone industry as well.
The optimist in me says no, and here's why. Follow the money. There is a huge, like $1 trillion economy that will emerge in the next 20 years around autonomous aircraft. And like this is like inventing at the same time the Wright brothers also coming up with the cell phone. Like you're talking about flight, and you're talking about like a radical new way of connecting people with data and how to actually analyze that ream of data. So I would say the insurance companies at some point will learn how to do risk adjusted for what the cost should be to enable this market. But right now, yeah, they can't figure out how to price it either. Yeah.
I'm curious to know what the long-term strategy is for how do you share airspace with autonomous drones and existing fleet of aircraft and the population of trained pilots. So what retrofit, if any, has to be done on the existing private aircraft, and what training, additional training, if any, has to be provided to human pilots so that collisions are avoided, so that autonomous drones and conventional aircraft can coexist in the same space.
Okay, if you guys didn't hear, like, what is being done so that on the general aviation, like the crewed aircraft side, what are they doing to be able to support the integration of?
What assumptions are you making about what retrofit, what training, additional training now has to be provided to pilots? And additional communication systems now have to be installed in all aircraft so that drones and aircraft can communicate. We're trying to avoid emergencies, so the deal with them and options in place.
Yeah, so it's a very good question, and I'll try and chew through it in a couple pieces. Everyone raise your hands. No, see, too late, too slow. And that exactly is the case, right? Those of you who raise your hands immediately, you're cooperative, right? So those of you who didn't raise your hands at all, or who were really slow to and you overthought it, non-cooperative, right? And these are actual technical terms. So aircraft that broadcast their current position, so a lot of general aviation will have a transponder, like ADS-B or such, and they're broadcasting their position. That's not the problem. The problem is, like, drones can then be able to receive that information and see you even if you can't see them. It's the non-cooperatives, the ones that are out there flying around, and a lot of general aviation don't broadcast their position, right? This is the scale of the challenge. So what does general aviation have to do? Well, one, it has to be prepared to radically pivot in a lot of cases. We're talking 100 years of really hard learned lessons, through 100 years ago from today. It's the barnstormers. There was no rules. People just got in something, and if they were crazy enough to fly it and they died in it, well, that's on them, right? Or they flew into the Empire State Building, right? A couple times. Sometimes with an Air Force bomber in one case. Like, this is how long it's taken 100 years to get here, and all that is about to change. And the reason why is quite simple. Non-cooperative aircraft are going to require detect and avoid. They're going to require a level of autonomy to achieve beyond just one-to-one, so one remotely piloted aircraft and one remote operator, to start going to one-to-many. That means autonomy, and that means it's like trying to compare an abacus to a supercomputer. Like, you're talking about decisions being made in thousands of times a second compared to a human. And in a lot of cases, if you start following this down the road, NASA's actually laid this out in a pretty clear white paper last spring. out of Florida at their FAA symposium. At some point, the question is going to be, when are human pilots unsafe to actually fly in the national airspace system? When you have millions of drones, and if it's 5 million drones by the end of this decade, you're looking at roughly 128-to-1 for a ratio between drones or uncrewed aircraft and general aviation. The skies are going to be filled with a lot of things. And an easy analogy here in Alberta is, how many cowboys do you see still riding on the side of the road? It's not safe for them, even though they should be able to, use the old trail. So at the core of your question, I think, and core of what we do and what everybody's trying to wrestle with, how do you self-separate? That's the core. Pilots can look out the window, they can see something, or they can listen to the radio and then move the flight controllers to maneuver an aircraft and keep that separation. The key challenge here is, how can drones self-separate? So detect and avoid, again, is the key technology required. On the general aviation side, there's a lot of questions that they're gonna have to look internally on. Yeah?
There's a lot of conversation going on about drone ID in the United States and remote ID for drones to publish their location so other air users can see where they are. Where do you see that going here in Canada? It seems to be a bit of a window and kind of a messed up situation over there. Do we want to have that here?
Well, I can't speak to what we want to have here. I mean, that's the regulator. And it's a really good question. So I don't actually have a really clear picture for you right now, but our COO, John Renew, the other guy with the shaved head, shaved, not bald, he actually works on the remote ID working committee or working groups. So if you're after this, I'm happy to connect you with him, John. Yeah. So I'll connect you offline after that, if that makes sense, and he can probably get you a better answer.
Question then. You talked about detect and avoid being the market opportunity, very, very important. I think you talked a lot about what you're doing with detect, but not so much about what's happening with the avoid side. That seems to me to be just as important. It's almost like it's two separate things.
Yeah, it is.
What are you?
So the avoidance, we call it an autonomous airspace awareness system. It is an autonomous detect and avoid system because one, it provides complete airspace awareness without a human operator having to manually look around or really try and actively use sensors on the aircraft, like a camera gimbal, for example. So what we're working on is there's some standards and some certifications and rules for remotely piloted aircraft, including detection. These are international standards. But when it comes to autonomy, there's no playbook, there's no rules. So as a very small startup, we actually work very closely with Transport Canada and a lot of our very big aerospace and defense partners on helping give them actual information. So in a couple of ways, when you look at what is safe and what is reliable, it has to be repeatable and scalable. So it's all about the math. So you can't just run a simulator, because a simulator won't give you the encounter of, what happens if a hawk comes flying by out of nowhere, which we've seen. So we do quite a bit of testing, both in the simulator side, as well as we do a lot of flying. So last year we did 254 flights with our aircraft, primarily centered around live autonomous avoidances. So we fly other drones in the path of our own drones, and we try and surprise them. And so far, that's how we're able to get those really reliable numbers on detection range. And then beyond that, we're working with a lot of the international standards bodies on, there's white papers that say, and there's like six avoidance maneuvers you might want to make. They're trying to figure out, theoretically, we're showing them, hey, empirically, these are how well our aircraft performed and our system performed against these 6. What do you think of that? And it's very much a back and forth between industry, regulators, in different types of industry too, like startups working with big companies. We can go a lot faster than they can. We can iterate a lot faster. Sometimes we have the right idea and we don't have to have a whole lot of bureaucratic approvals that take years. So it's a complex question that you asked, but in short, we're finding out in real time pretty much every week what the avoidances really need to look like for ourselves and for the wider kind of regulatory space.
Carl, exciting to see companies like Pegasus grow here in Edmonton and Alberta. Can you tell everyone a little bit about your background and about your team?
Yeah, I love talking about the team. My background is actually, I was in the Army stationed here in Edmonton for 15 years, in the infantry of all things. So starting an aerospace company made complete sense. But I love the military. I would have stayed in forever. Leaving the military after a medical release in 2018, I had to try and find what my next mission would be. And like, you got to remember, 5 years ago, this is something that's really hard to even talk to your wife about. Like, I have an idea. She's like, you're gonna get a job. I'm like, this could be it. I'm like, this seems like the big mission, right? The next big step. And along the way, we've gone from 1 to 2, and now there's 26 full time. So a few months after leaving the military, I went to a pitch competition down in Calgary, absolutely tanked it, because I literally just gave a military back brief. Like, this is the mission, this is what we're gonna do, here's our plan, and people are like, oh, that's not how you pitch. I'm like, well, that's how you brief, so we're doing it. So I've been in the Army for my whole life to that point. Anyways, one of the judges is from Silicon Valley. I got a scholarship, went down there, and I guess I bring this up because we've been down to Silicon Valley. We came first in programs down there. Like, we know what the potential of this company is, and we're building it pretty much every day since. So why are we doing that from Silicon Valley now all the way up here north of the wall, so to speak? There's a lot of really good reasons. The regulator here in Canada is forward-leaning on autonomy as the long-term future. You look around Edmonton, a lot of it's remote and isolated airspace. Perfect places to go and test, with low risk to the population or infrastructure. And it just so happens Alberta is the home of the economic engine of a G7 country. So it's the perfect place to both develop and then commercialize in the same area code as a lot of our target markets. So to date, we've had really good success. A lot of the team is aviation experts. Like, our chief pilot is actually a helicopter instructor pilot we stole from a neighboring company a couple years ago. Yeah, I know, we owe some people beers. And then a really talented engineering team, and then we basically try and fuse as much as possible the people who are going to take this technology and build it with the other half of the company, which is about deploying it and working with people, on the coal face, working with people in rail or wildfire, and then having them share that information back and forth.
And what are your hiring plans for the next 5 years out?
Well, you can find out live if you follow us on social media. It's at Pegasus Imagery on Twitter. We have a website, pegasusimagery.ca. We're actively looking for a couple roles right now on the finance and on the engineering side. And we'll be, ideally, later this summer, looking to grow the company again. So we've been able to double the size of the company year over year, even through COVID. And I think that's entirely not based on me. It's based on the culture of the company. So do hard shit.
Outstanding. Thank you very much.
Oh, sorry. Thanks, guys.